for having us at this first PAASTA conference. It's been a really great day. And we just talked about having more collaborative community projects, and this is actually one of them. So I'll be presenting on behalf of one of PAASTA's community projects, which is ProteoBank. And with a group of people, we're developing an open access community curated database of ZooMS peptide markers, specifically focused on collagen. So we've seen this slide already with Sam's talk in the early morning, but ZooMS has really expanded exponentially over the last 15 years. This graph only goes to 2019, but we've seen so much development, both in terms of taxa, for which we have markers available, geographic range of where these species are coming from, the developments with fish, birds, reptiles, amphibians, and so on. It's really been a big growth in the field, and it's really established ZooMS as a big field in biomolecular archaeology. But when we look at the reference databases that we're all using, I think most of you, if not all of you, will be familiar with the spreadsheet that's been hosted by the University of York. It's a spreadsheet which is openly accessible with ZooMS peptide markers for everything that's been published. And it's being upheld by the University of York, as I just mentioned, and it's something that a lot of people use to make species identifications with ZooMS. Alternatively, people also host their own Excel spreadsheets, maybe, which will allow for maybe easier filtering or how you prefer your data. But the main issue with all of these spreadsheets is that there's nothing that's actually citable or version controlled available that we can use in publications to show exactly what reference database we use to come to the identifications that we make. So that's where this project stems from. We wanted to create a new open access community curated database of all of these ZooMS peptide markers, starting with collagen. So this is a very collaborative project, and we aim to make this open access, version controlled and citable, with new versions coming out every 3 to 6 months, preferably. And the main thing of this database is that it will also be reviewed and openly accessible for everyone to use. We want to make it we want to integrate it with computational tools, both for submission of new data, but also at the back end, which I'll talk about more later. And the database will be pivoted around the, I wouldn't say new anymore, but the ZooMS marker nomenclature that Sam introduced in 2021. So here's a quick overview of the structure, and just to give a little side note, we're still fully working on this database, so we'll be really happy to get more input from people or more feedback. But for now, this is the basic structure that we have in mind for this database. So at the beginning, there's a submission tool where anyone would be able to submit new markers to the database. This will be controlled with a set nomenclature and set vocabulary. And it will also be checked with the computational tool that everything fits according to, for example, the naming of the marker, so that everything fits in the same structure. Then these new submissions will be reviewed by a core reviewing team. And then there'll be input into the main structure of the database, which you can see in the middle of the database. I'm not sure if you can see my my mouse, but the main aspects of the database are the markers themselves, obviously. So this would be the mass of the marker, the ID of which marker it is. We also want to record sequence information so that it's easily accessible and findable if you want to know the sequence that corresponds to a marker mass. And of course, also information about the organism that the marker is from. So species, genus, and family, where this particular species occurs in the world, whether it's domesticated or not. We want to include the information from the original data set that the marker is coming from. That includes the name of the project, what's the publication, what's the DOI, so people can always refer back to the original publication that this data was recorded in. And then if there's any sequence information available on UniPro or NCBI or any other database, an accession number and a link to it, so people can also find the full sequence of the collagen as well. Then that makes up the main body of the database. And then at the back end, we'll have computational tools that will allow for filtering and browsing of the database. That will also allow for you to pull up a simple Excel spreadsheet version of the database so that it's easy to use also for people who are less knowledgeable with either computational tools or with people who are new to the field, to still make it easily accessible for everyone to use. But then at the same time, we want to develop some computational tools that allow you to maybe make species identifications, link it also to existing tools like species scan or other software that's already applicable, maybe being able to do maybe de-annotation or data visualization as well. So we want to make this in a way that it's that we can easily incorporate it with existing and new computational tools as well. So here's a quick example of one of the records in the database. So one of the first things we obviously need to do, since this would be a new database, is to record all the already existing markers in the database. And we also sort of use this as a little test to see how well the structure that we thought of would actually function. So what you see here is the relational database, which is sort of the backside of how the database looks, of markers that we pulled from the Buckley et al. 2010 paper on sheep and goat. So what you see is different tables that all relate to each other based on the IDs. So for example, you have marker 1, and it links back to marker 1 here. Taxon ID here links to taxon ID here. So that's kind of what we mean with the relational database. So we input the data for all these species from Buckley's 2010 paper. And as you can see, we highlighted here the nomenclature column, since it's one of the main pivoting points of the database. So this is, for example, if you want to then query the database or add new information to the database with the submission tool, it would be added onto or queried from these tables. So you could, for example, query, give me all markers with nomenclature X, or give me all the markers for family Y. So it would allow you to pull all the information quickly from the database. So we want to host this on GitHub, and it's mostly inspired by the already existing database called Ancient Metagenome there. And we think GitHub is the ideal place to host this data, since it allows for collaborative data submission, revision, but also discussions once something's already been uploaded, so you could make changes to it as well. Then also by hosting it on GitHub, we can also make specific versions and releases of the database that can be archived in Zenodo and released with a DOI, so it can be citable for publications or other types of studies you want to do. And then finally, by hosting it on GitHub, it will also allow people to fork the database and take it into their own direction. So if they want to do something specific with it, they can take it and change it and alter it the way that they want to do it. But it would still allow you to track it back to an already released version as well. I know this was quite quick, but it's still a work in progress, and we are really keen to get more feedback or ideas or insights from the community. And before we actually started to build the database, we wanted to get more feedback from everyone. And we're also very open to have more people join us in this endeavor. So if you are keen to join us, or if you have any feedback, just let us know. You can either just reach out to one of us, or you can join us on the Slack channel of PAASTA with #ZooMS. So you can join us there, and we'd be happy to have more people working on this. Thank you.